In this module, we will look into how to create assemblies, a concept of assemblies, and how to build assembly from various parts. So first we're going to cover the overall concept of assembly and its types. Then we'll look at the three different types of mates. First is standard, second advanced, and third is mechanical mates. And after learning these three, we are going to have a practices on various assemblies. Basically, assembly is simply putting two or more parts together. So they are joined together by applying constraints. Here in SOLIDWORKS, those constraints referred as mates. You can create assembly in assembly environment by using two approach. So you can say there are two methods. One is bottom up assembly approach and second is top down. Now here in first case, we'll create separate parts and save them in a separate file and call them one by one to create an assembly. So it is useful where parts do not rely on each other's geometry. They are separate. Let's say I have a bracket like this and I want to fix on a simple wall. So bracket geometry is not dependent on wall. So here I have a drill, simple hole, and then I'm going to use the nut and bolt to fix this. So all these three parts can be manufactured separately and can be bring here to create the assembly. They are independent of their geometry. If this is the case, then bottom up assembly approach is best suitable. In case of top-down assembly approach, where the parts are basically designed in assembly environment, they are connected through their designs. Their dimensions are dependent on each others. So in case your design parts are inside assembly, referencing other parts, then you have to use this top-down approach. For example, frame, sheet metal, plastic, weldments. Let's take the classic example of gasket. Let's say you have a cylinder block over here. So these are the cylinders. Now on the top, we have to put the gasket to prevent the leakage of engine cycle. So the dimension of this gasket depend on the outer dimension of the cylinder block. The moment it changes, the dimension of gasket is also changes. So here the gasket dimension depends on another component. If this is the requirement, then you have to go for the top-down assembly approach. In this module, we are going to basically cover the bottom-up assembly approach. Now, moment you start the new documents, earlier we have seen how to create the parts. Now for assembly, you have to choose this one. Now, when you begin with the assembly creation, you'll be offered or property manager, you can say. Here you have to open the documents. Now you can insert the parts. You can also insert the assembly as well. Assume that you have a big machines where the machine is divided in smaller assemblies. So each assembly is prepared separately and that assembly is called in a larger or the higher level of assembly. So you can insert part and assembly. Now we have options over here. So because it is tick, it says that start command when creating the new assembly. So because of this, we have this property manager activated upon creating the assembly documents. Then we have important things like only fix the first component. By default, it is ticked. So moment you insert the first component, its degree of freedom is 0. It is but natural if you have a common sense that when you create the assembly, you need to fix the first component on the bench table or in vice or somewhere. Then you are going to put the other component on each other, right? So this with that concept, by default, this option is ticked. Now what is the approach basically? Create an assembly document as shown over here, then start inserting the components, then add the mates between this component and modify if it's required. So this is general flow of bottom-up assembly approach. Now moment you add a component in assembly environment, your property manager grow, right? The first component you enter is having basically F symbol. F stand for fix. Because as discussed earlier, the only assembly in assembly environment, SOLIDWORKS is going to fix the first component. Then subsequently you will see the minus symbol. Minus symbol indicate that the component has not fully defined or fully constrained. It is free to move in particular directions. So sometimes you need to control the degree of freedom. The first component which you enter in the assembly has got degree of freedom 0. Now what is degree of freedom? It's a movement in XYZ direction and rotation about XYZ. So total 6 degree of freedom is available in space for particular part. So you can see from this image. Now as you add the subsequent component, you may require to add constraint and manage to degree of freedom through the mates. Now we have basically 4 types of mates: the standard, advanced and mechanical. We are going to see these advanced, standard and mechanical. Now if you look at very carefully, so it is not just fixing the degree of freedom of component, but also about maintaining actual relationship between them in the same way as in real world assembly. And for this purpose we use the mates. You need to allow a movable component of assembly to move freely in respective directions, and that is possible through by applying the respective mates. For example, the function of the shaft in assembly is to rotate about axis. So you cannot have a 0 degree of freedom for the shaft. You should allow rotation about particular axis. So therefore you need to retain its rotational degree of freedom so that it can free rotate. So remember, while you apply this constraint, make sure it simply mimic the real environment movement of a component in assembly. Just look at very carefully in standard mates. What we have is coincident, parallel, perpendicular, tangent, concentric. Now from the name you can simply understand what does it means, right? Here we will have a surfaces parallel to in the same plane. We'll see all this in detail through exercise. But the standard mates are basically very easy to understand. Now in standard mates, we'll have basically the coincident, parallel, and you can say the perpendicular, concentric, tangent. Basically standard mates are used for positioning the component. Remember this positioning of component, and that is the main purpose of this standard mates, by restricting and reducing the degree of freedom of a component. You can say basically there are 8 standard mates, and apart from that we have alignment. So alignment means what? The selected faces will be remain in same direction and then body part in same direction. Here the faces are aligned but the bodies are opposite in direction. So it is called align and anti-alignment orientations. Now through exercise 9.1 we will explore how to use coincident mate. Now coincident mates basically makes 2 faces edges or points line on a same plane or touch each other. Now see, we have 2 parts over here. I want to assemble them. So I need to coincident any surface. Let's say this is top surface and this is bottom surface. They need to be on a same plane. Again, then we have to apply another mates so that these surfaces remain aligned. That is coincident. And lastly, for this. So by going through this way, we are able to create a fully constrained assembly. Let's see in SOLIDWORKS. Now in SOLIDWORKS, you can start assembly environment over here by clicking the new documents. From here, choose the assembly and click OK. Moment you do that, because what we have discussed earlier, the start command when creating new document, this start this property manager and immediately ask to add the components. So this is default behavior of assembly environment of a SOLIDWORKS. Now I want to add a component. So here I am going to add this component and I will press the control to add 2 components together. Click open. Now here I have 2 components, 1 and 2nd. Now see what we have. The first part, when I choose the property manager, it's highlight the particular part in graphics window, and this is my 2nd part. Now see, the first part is basically having F later. That means it is fixed. You cannot move it. Now let's try to create the mate between these 2 faces. So for that, either you can go to the mate and make sure the standard mates is active, and choose the surface, this one and this one, like this, and click OK. Now see, because of that, these two surfaces are aligned. Look at this. Okay. Now let's add few more constraints. So select this surface and this surface. They get aligned, and click this green tick, or either you can go over here and tick. So better option is use this shortcut toolbar. Now let's choose this face and this face and right click. Now we have a fully defined assembly of our two parts. Now I cannot drag this because it is now fully defined. Clear? So by applying 3 coincident mate, now how can you identify which coincident mate is it? Just go and hover over your mouse so you can have an idea that the coincident mate is applied between which surfaces. Let's say you want to modify anything. So select this and click on edit. So you can change the surfaces. So it is very simple. Now let's close again. Let's start the assembly environment again. Now this time I'm not going to add the component this way. Simple, I will cancel everything and I will choose this option assembly and insert component. From that I will choose first component, which is fixed part. So component 1, add it. Now moment it comes, it allow me to rotate. I can rotate its orientations, but I don't want to do that. I will simply go and click OK. So it get added to the assembly environment with letter F, that means fix. Now let's insert another component and click OK. Now let's say you want to rotate this part. So right click on this part and try to rotate it, because sometimes you require to rotate the part to set the proper orientations. So you can do like this, right click and rotate. Now select this, press Ctrl and select these two surfaces. So when you release the control button, the shortcut menu for the standard mate is available. So click on coincident. Same way, select this and control this surface. Again continue with same way. Now rotate your assembly, select this surface, control, select this surface and coincident and right click. Okay. Now let's try to edit the orientation over here. Now here what we have is this orientation. So when I flip this, see, error is throwing. The reason is because let me disable the remaining two. Now let's edit the first one. Here I have the aligned and anti-aligned. So try to understand what does it mean. Let me zoom in. Here the two selected surface are aligned, but their body parts are in the same direction. So here these are the two surfaces. So their body part or body mass is in a one direction. But we don't want this kind of assembly. So I have to switch to another option called anti-alignment. So here you need to explore yourself that which alignment option works for your assembly. So this way you can use coincident mates to create the assembly between two parts. Now through exercise 9.2, we will explore concentric mate, then parallel mate, and then perpendicular mate. Now words itself is self-explanatory. Here in concentric mate, it simply align the center of circles. Easy to understand. Center of circles, arc and cylindrical surfaces. Now where they are basically used? They use for assembly of bolts, shaft and bearing. In general, when you want to assemble the circular shape, you require to use this concentric mate. Here in this exercise, we are going to concentric these cylindrical surfaces, and then we are going to have a coincident mate between this bottom surface and this top surface. So start new assembly. Now here I'll go with the default settings and I will choose the respective parts. So first part will be our link and click open. So I will add it like this. So look at on your design tree, the component is added. Now let's insert another circular pin. Click OK. Now let's say I want to add one more pin. So instead of going insert component, you can press Ctrl and drag it. It will create the copy of a same component. So let's undo. Now let's apply first the concentric mate. So you can go over here and start the concentric mate by clicking this part and select the two surfaces. But I'll show you the better way. Select this, press Ctrl and select the circular surface. Immediately this pop-up toolbar, that is shortcut for the mates, is available, and choose from that concentric. Now see, what does it mean? These two cylindrical surfaces are aligned, but this is not what we want. We still need some more mates to complete this assembly. So I need to coincident this surface with the bottom surface. So choose this one and press Ctrl, choose this one and make sure it is coincident. Again, as you see, if you closely see that the shaft, this pin is still rotating, right? So here it shows that it is underdefined. Now how can I stop the rotation of this pin? For that I have to choose any plane of that part, let's say front plane, and I have to choose the front plane of the assembly environment, and I have to make them parallel, and that will stop the rotation of pin. I'll do that later. So this way, by using concentric mate, you can assemble the circular surfaces. Now let's apply parallel mate. For that I need to add one more link. So I can add from here, insert this part, or simply I can create a duplicate of it. So press Ctrl and drag this part, and that will create the duplicate copy of a component. It's basically, it is equivalent to inserting the another component. So let's right click and delete this part and try inserting in this way. It's the same thing. Now let's try to apply first concentric mate, then this surface and this surface coincident mate. Okay. Now still this upper link is free to rotate about this cylindrical surface. Now I want to make this surface and this surface parallel, and that is called parallel mate. So for that I can go over here and click these options and then select the surfaces. But better option is select these two surfaces, press Ctrl and select this option parallel. That is shortest way. It will save your time. So this way what we have is basically it simply makes this surface parallel to the bottom surface. Now like feature, you can also edit the mates you have created. For example, I want to stop this parallel mates. So right click and suppress it. Now I can rotate the link. So moment I unsuppress it, it come back to the mate conditions. Now let's go and try again to edit this mate. Now here I will try these alignment options. See what happened here. Okay, like this. So same thing is accessible from here, from the shortcut menu. Either you can do from here or either from this short toolbar, right? So this way, by using alignment option, you can simply assemble your component as per your requirement. A perpendicular relationship between this surface and this surface. For that I need to suppress this parallel mate. Otherwise I cannot make this surface perpendicular. Now select this surface, press Ctrl this surface and choose perpendicular. So this way you can create a perpendicular relationship between two surfaces. Now see what happened if I unsuppress this. It is but natural, it is going to throw the error. When two surfaces are parallel, how they can be perpendicular? So it shows mate error. You may come across, so you need to just go through the mates and see which one is conflicting. So let me suppress this. So SolidWorks immediately solve the assembly. Now in Tangent Mate, basically it forces a curved surface. So this is our curved surface. So it is made up of circle, cylindrical or spherical geometry, which will force to touch the planar surface or curved surface. So here what we have is like a slot and then we have a pin. So in between we are going to create the tangent relationship. Now create new assembly. Either you can add parts later like this, just cancel this dialog box and go over here in assembly tab and insert the component. It's the same thing. Better option is to continue with the default settings. Now here I have to, let's go and see the larger icon. So I can add the parts. So this is my first part and open this. Make sure it is visible in window, graphic window and click OK. So it will, by default, its geometry or origin will fix with the origin of the assembly. Now let's insert the pin. Now let's apply the tangent mate. So select this surface and control, press and select this surface and release it and choose this tangent. Same is also available in mate. Click on tangent, then select these two surfaces, right? So let's cancel this again and let's try in a simple way. Select this, press control, select this and choose the tangent. Now see over here, what we have is flip the mate alignment. If I flip it, it simply orient the cylindrical surface on this side. So let's go ahead and edit this part. And let's flip back to its original positions and click OK. Now no doubt it is tangent. It is tangent, but still it is moving up and down. So I need to add the coincident mate. So select this and select this surface and coincident. Now you can see if I drag this, it is reciprocating in the slot. So this is our desired result of assembly. So you need to be careful what kind of mates is required between two components. In this case, we have added two mates. One is tangent and second is coincident. Coincident mate is used to align the bottom surface of this link. Otherwise, it will simply move up and down, right? Now here, if you drag further, it simply goes out of a link. But we are going to fix this motion of a pin from left to the right at maximum through advanced mate. Now in a distance mate under the standard category, it basically sets a fixed distance between two faces, edges or selected points. I repeat, it set fixed distance. That means the component will be located from the reference surface at particular distance. It is not going to move. So we have two parts which are assembled in this way, and later we are going to apply the distance mate. So start new assembly. This time I am going to insert this base part. Click OK. Let's insert remaining part and click OK. Now select this top surface, middle mouse button to rotate the assembly, press Ctrl and select this and make it coincident. Okay. Now say it is not proper. So what we can do, select this surface, press Ctrl, select this surface and make the coincident. Now it is going to reciprocate. So because of fixing 2 degrees of freedom, we are having desired motions. Now I want to fix this movement by setting the distance mate. So select this surface, press Ctrl this surface and you can choose this distance. Okay, you can do from here too. So click on mate and select this distance and now select the two surfaces. Now let's enter the distance. Let's say 20. Now if I flip this, what will happen? Obviously the distance direction will change, left or right. Okay. Now go ahead and click OK. So this way you can simply apply the distance mate between two selected surface or two edges. Now let's try to apply. Now instead of creating new assembly, we'll open, and this time let's activate the filter and select this assembly. So it's a 9.6 distance underscore circular assembly. Here I have applied first the coincident mate. So through color coding you can see which surfaces are having coincidence. So this is first and this is second. Okay, so second, simply align these pins. Now lastly we have applied the distance mate. So here distance is from center to center. So let's try to edit it. So moment you do, here new things available. That is, the sub option shows that the distance is from center to center. Now instead you can simply use minimum distance. That means from this surface, outer surface to outer surface distance is 50. If you choose maximum distance, that means from this left side to the right side is remain 50. And last option is custom. You can choose any two combinations. Okay. So let's try center and minimum. Okay. So this way you can apply the distance between two circular surfaces. So moment you selected two circular surfaces, as we saw here, you have to choose the option called from center to center or from minimum maximum options. Now in 9.7 exercise, we will learn how to apply angle mate. Now name suggests it's simply going to create angle between two selected faces or edges. So as you can see over here, these are the two edges. Now again, as you can see in these two parts are having angular relationship. So either you can change the direction of angle and also you can change the mate alignment, aligned and anti-aligned. Now create new assembly. Here I'm going to insert the first part. Now let's insert the second component. Click OK. Now here because it is not properly aligned, I will right click and try to rotate it. Now let's apply the concentric mate between two surfaces. So select this surface and press Ctrl. Then this surface and control this top surface for coincident. Now here it is now properly fixed at the location, but still we are allowing it to rotate about the pin. Now let's apply the angle mate. So either you can go over here and start the mate and choose the angle mate, or other option is simply select the respective edges. Let's say this one and press Ctrl this one, and from here choose the angle. Now let's say I want to apply 45 degree. Now if I click these options, which will simply flip the dimensions. Look at this, like left and right. So from horizontal axis it is above. If I flip it again, it will flip the direction on the bottom side. Okay. Now again I have flip mate alignment. If I click this, it simply take opposite side. Now let's try in a similar way over here and let's try again. So there are two variation from the dimensions and two variation from the alignment mate. So based on the requirement, you can choose this option to create the angle mate. Go ahead and click OK. Now you can expand this and you can change the value. Just select this and double click this value. Let's say this time it is now 80. And rebuild. So part will reflect these changes in assembly.